Sequential learning is basically learning the events that happen in a continuous series, and their happening depends on the various event. A text is not exactly sequential data, but to understand the complete meaning of the sentence, we need to understand its proper arrangement of words. Even a single word has some meaning, but the intention of the text is clearly understood only by understanding the sequential arrangement of words in a sentence and the sequential arrangements of sentences within the text. That is, we can't understand the meaning by randomly picking words or sentence from the text. We need to go one by one in a sequence in the arrangement. In today's session, we discussed how these main NLP algorithms handle sequential data, that is textual data. First are RNN and its variant LSTM and bidirectional LSTM. Second is BERT, and we discuss its component self-attention and multi-headed self-attention. Recurrent neural networks have the ability to learn long-term dependencies, that is, they can carry forward information in a long sequence. But as the length of the sequence increased, it faced the vanishing gradient problem. Vanishing gradient means that as the model moves in a sequence and learns about new things, it forgets about the things it learned in the past. And in this way, it loses important information from the past. LSTM handles this vanishing gradient problem well to a particular extent. In LSTM, the model decides by itself which information it needs to take for a longer perspective and which one it needs to drop with the help of its three important gates. Input gate decide which information model needs to be updated. Forget gate decides which information model to keep or reject. Output gate decides which information model will provide as output. Bidirectional LSTM are able to handle this problem, and they do well on long sequences. Bi-LSTM, as the name suggests, are LSTM network with two directions. That is the forward pass and the backward pass, means they do the same operation in a sequence from both directions. Because of this, if any information is missed or dropped by the model that is important in the forward pass, it can be considered in the backward pass. That's how the model sees the input sequence in both directions and gain much better insight from it. BERT is basically a bidirectional encoder decoder. BERT does not take input data in a sequence, but it takes the input sequence data as a whole and looks into it in both directions. That's why it's called bidirectional. BERT was not designed like previous NLP models that take the text information in sequence, but it was designed like convolution networks like in Vision. BERT has lots of theory and use cases, and I think the session is not enough for this. So I suggest you to see these things on the internet. Let's discuss its two important components. The self-attention mechanism is basically the relationship of the word in a sequence to its nearest neighbor. In this input text, vectors are fed into the module as query, key, and value to get the attention score of the word to its nearest neighbors. And it returns an attention score, which is also a vector. Multi-headed attention is a similar concept to self-attention, but here the self-attention process is done parallelly over a number of times, which we call the number of heads. The number of heads is the number of neighbors up to which we think that model should need focus to get the complete meaning of the sentence. And that concludes the discussion. Please accept my gratitude for your time and consideration. Thank you.